So what we're looking for when we're trying to interpret these is identify any branches with large amounts of change. It could be backwards and forwards or just many more characteristics coming on. Some risks have a lot more diversity than others. Is there any pattern to that? You know, what's going on in that particular clade? Are there certain co-evolution going on in there, or is there some pattern to the way that these characters are evolving? Most risks, sorry, I'm jumping around there, look for the ones with the most characters, that's maybe what we just looked at, and see whether they're likely to change again. The risks should be getting more complex over time. This is almost in the same way of saying you can date a hedge by the number of species in it. And indeed, that's what people do. So if you've got only one species of a hawthorn in a hedge, it's not a very old hedge. So there is some basis for saying that we should be expecting risks to be more complex. Now, okay, this is not a hedge, these are all perceptions, as Patrick's mentioned, but that's what we look for. So if we're losing characters on there, that is kind of telling us something. And this idea of co-evolution, what we do spot is where this character is always with that character. Now that might be, again, bad description of the risks, but we know if we spot a risk that doesn't have both those characters, it's very likely that the second is going to be picked up. If it's got one, the other's more likely to come along. So this is the approach, and that's labelled up a little bit more, and we can start looking at there's economic downturn, repeat catastrophic weather events, and the implementation of periodic payments is an area that we would be really watching quite carefully. And of course, you know, repeat catastrophic events we could imagine with periodic payments, and Neil or another actuary would have to explain me exactly the detail of that. But we could start looking at what, if we now think about some of the characteristics on Island 9 and Island 10, combining and switching, would that give us a new risk? Now we can focus our risk scenario workshops, not just to be about anything, but actually start looking at some smarts in there. Okay, I'm going to push through to the next one. This is the UK. The UK has a slightly more interesting and a bit more stable set of cascading or bifurcating risks down here. We also sometimes get risks where you have multification. What this means is these have all occurred at the same time. So when we get sort of mass multiplication, that there's something that's triggered all this. And you think, oh, come on, how does that actually happen? But regulation does that. So regulation in a risk sense would cause that. So there's a new character, and therefore we'll find that we get lots spilling off. MissQuick is quite a neat program because it provides us with this as well, which is giving us an idea of the frequency of parsimony steps, which is the number of times that a character will change. It's picking that up for the whole data set. And it's looking at the frequency of how many risks is that character in. So now we can say, well, this up here is actually changing a lot, but it's also actually in a lot of risks. So that might, whilst that's very interesting, that is actually maybe to be expected because it's in more risks. This one is actually changing very often, but is in less risks. You know, this is interesting. So from that analysis, we're saying that this is a cluster that is following a bit of a norm of the number of changes per risk. And what this does is maybe say, well, pricing is that top one, and the colours are slightly weird on here, but changing claims patterns is this one. So these are our kind of outliers that we would look at for characteristics. They're in lots of risks and they're changing a lot. That's the whole risk map combined. It's kind of horrid, but it does behave the same as the individual ones in the analysis. Yes, you get a little bit more of a headache trying to look at this, but the same idea. Here we've got the grandfather of this rather large clade here is expenses overrun, which I heard Neil say that was surprising the other day. And here we have pricing is the root of that group of risks. And again, this sort of area here, we're seeing lots of change coming here, bifurcation, and this looks like a very busy area. With the characters on here, there are a lot of changes going on here. This is actually catastrophic risk, weather risk, and terrorism across 3 different countries. So there's a bit of connection here. So now we've got Scandinavia, Ireland, and UK. Those risks are actually looking very similar, and why? For this overall organisation, they can start spotting straight away that there seems to be a possibility for new emerging risks coming out of this much more than some of the other combinations. And it's around catastrophic risk and the reinsurance of that. So really sort of taking that table, we can look at the number of descendant risks of a particular evolutionary character, what the clade is, and make some assessment. We can start looking at a little bit of co-evolution, and I'll just do one of these. For example, we look at Island 9, the risk is inadequate data privacy procedures might gain a media character. Why? From the data, we can be quite strong about that, because media, which is 53, only evolves in the presence of investors and JP partners. So the risks that have that may gain media, and this has JV partners but not yet media. So what I'd be saying is this risk here, what would it look like if there was a media characteristic to it? Would we call it something new? Is this now a more sophisticated version of this, or what? But certainly intuitively to me is that would be data privacy, media, yeah, you've got another problem. That looks like a different risk that you haven't thought about yet. We don't see that anywhere else in your risks, but it might be one you could be exposed to. So that's the sort of thing, and there's another example down there of this idea of co-evolution. So we're always seeing these together. If we don't see them together, then there's a very strong possibility that one of them will be added on. And lastly, the connectivity aspect, we look at on that matrix, we look at a distance matrix there, but taking out any characters that are not seen anywhere else, and we get a very robust connectivity factor, which we then use to adjust the normal impact times probability assessment. We say add in connectivity, and that gives a factor, albeit it needs to be normalized. So this is looking a bit like DNA. Collective risk systems evolve and co-evolve. This past dependency, of course, insurance industry knows that the history is important from individuals, from a medical, from motor car insurance. They know that. Here is another way of looking at this. The progression can be analysed, and predictions about how risks might be developed, and I'd call that emerging risks, and really an interesting way to classify and manage risks.